In this video, we will discuss how a plastic part is made inside a injection mold. Before going to discuss this, we will discuss some very basic concepts which are very essential to the design of injection molds. And the first concept is molding. Now, in our technical language, we do not call a plastic part a plastic part. We call it a molding. You are seeing that this is a plastic part. This is a plastic part. So we do not call it a plastic part. We call it a molding because it is molded inside a injection mold. It is molded inside a injection mold. So the plastic part which is produced by the injection mold will be called a molding. Molding. So the concept of molding is that a plastic part which is produced by a injection mold is known as molding. So this is the concept of molding. Now we come to the most essential and important concept in injection mold design is that what is a cavity and what is a core. Cavity and core. What is a cavity? What is a core? Now you are seeing that this is a molding, as we have already discussed. This is a molding. Now it has got two surfaces. One is the outer surface. This is the outer surface. This is the outer surface. This is the outer surface, all four sides, and this bottom is the outer surface. Now there is an inside surface. This is the inside surface, and all the sides, all four sides, they are part of the inside surface or the inside shape. So if we imagine that there is an outside surface and there is an inside surface, and the material is filled between the outside surface and the inside surface. So we will get our molding. Now the component or the part of the mold which forms the outside surface or the outside shape is known as cavity. So this is the outside surface and this will be formed by the cavity. Now I will show you now this is the cavity insert, not a cavity, and this yellow portion is cavity. That is what we are discussing. This yellow portion is cavity. Now if I put this molding inside, it goes, and the outside surface of the molding is touching the yellow portion. So the outside surface will be formed by that yellow portion, and that yellow portion is known as the cavity. That yellow portion is known as the cavity. This is cavity. So the concept is that if in the molding there is a outside surface, this outside surface is not a cavity, it is a solid portion, it is a male portion, but the cavity is a depression, so it is reverse of the outside shape, it is reverse of the outside shape. So this is the concept of cavity, this is the concept of cavity. So now let us summarize it. What is a cavity? Cavity is a shape or a surface which forms the outside surface or the shape of the molding. Normally it is a cavity, that is, it is a depression. It is a depression. So cavity we have understood. Now we will come to the cavity insert. Cavity insert. What I am holding is a cavity insert. That means this yellow portion is cavity and the whole thing including this block is a cavity insert. This cavity is to be retained somewhere. So we take a small block of mold steel or tool steel and we create a cavity inside the block. Inside the block. So that becomes the cavity insert. That becomes the cavity insert. What I am holding is a cavity insert. So what is a cavity insert? Cavity insert is a small block of mold steel containing cavity. Containing cavity. So this is the small block of mold steel and it contains this cavity, that is the yellow portion. So this is the concept of cavity insert. Now we will discuss the core. What is a core and core insert? Now I have shown you molding, this molding, and as I said, it has got a inner surface or the inner shape, inner shape. So uh, if I put this molding over this core, this is the core insert. This is the core insert. What you are seeing is a core insert. That is, this total block, including this red portion, is a core insert, and this red portion is core. Red portion is core. So if I put the molding over it, it will go here. And the red portion, this red portion will be in touch with the inner surface or the inner shape of the molding. That means this red portion will give the inner shape of the molding. So what is a core? Core is a male member. You can see that this is a male member which forms the inner surface or the inner shape of the molding. Inner shape of the molding. So this is the concept of core. Core will be normally a male portion, and in the molding you can see it is a depression or it is a sort of a cavity. So the core is reverse of the inner shape of the molding. Now we come to the core insert. Now you are seeing that this whole block, including this red portion, that is this red portion and this green portion, that is the complete block is core insert. Core insert. This core is to be retained somewhere, so we add a small block and then this will be retained in the core plate. So this whole block is a core insert and this red portion is core. So let us summarize it. What is a core? What is a core insert? Core insert contains the core, this red portion. It is made of mold steel. It is made of mold steel. So core insert is a small block of mold steel containing core, this red portion. So we have discussed 5 concepts, that is molding, cavity, cavity insert, core and core insert. Now the concept of core and cavity and the core and cavity insert is very important and it is not very difficult to understand. Now we come to the concept of impression. Impression. What is a impression? Now in a mold, this cavity insert will be fitted into the cavity plate and the core insert will be fitted into the core plate. An injection mold is always in two halves. Is always into two halves. One half is called a fixed half and the other half is called a moving half because it moves. It moves. So when the mold is closed, what happens that this core and the cavity, they get assembled. They get assembled like this. They get assembled like this. Now the core dimensions are less than the cavity dimensions. The core dimensions are less than the cavity dimensions, and when they are assembled like this, there is a space between core and cavity. Between core and cavity. Now I can demonstrate you that this moves. See, this is moving lengthwise and this is moving widthwise. This is moving widthwise. This is moving widthwise and this is moving lengthwise. There is a gap also in the height wise, but I cannot show you. So when the mold is closed, the cavity and core, they get assembled and a space is created between them because the dimensions of the core are less than cavity by the wall thickness of the molding. Wall thickness of the molding. Now to make the concept still clear, I have developed a core. This is only a core, not a core insert. Not a core insert. And I have these small pieces, these yellow pieces on all the sides. You can see all the sides and at the bottom. At the bottom. So now I will put this core inside the cavity. Now I will put this core inside the cavity. So these small pieces which I have put, yellow pieces, they will centralize this core inside the cavity. Inside the cavity. Now you can see that this core, this is the core only, not core insert. This core has got centralized in the cavity, and now you can see there is a space all around the core, that is around the side walls of the core and the side walls of the cavity. There is a space, and at the bottom also there is a space, that is the bottom surface of the core and the surface of the cavity, there is a space. So when the core and cavity get assembled, this kind of space is created between them. So this space which is created between the core and cavity is known as impression. Is known as impression. So now how the molding is formed? Now you can see that this is a runner channel, and here you can see a white portion. This is known as gate. The plastic material will come from this runner channel, and it will come through the gate, and it will impinge on the side wall of the core, and it will get distributed into this hollow space, because the material comes with a high speed, high velocity, and is a high pressure. It gets distributed. Correct. Now see, this surface is at the same level as this. Is this. Now I can put some packing so that it is more clear. So now I have put the packing, so this surface has come at the same level as this surface of the cavity insert. Correct. Now the gate, this white portion is below this surface. So if the material comes, see, if material comes through this runner channel and it passes through the gate, so it will impinge on the side wall of the core, and it will get distributed into the hollow space. So this hollow space is in the shape of molding. So now I will put the core insert here. This is the core insert, and I am putting this core insert. So the material will come from here. It will go through the runner channel. This is the runner channel. It will go through the gate. It will impinge on the side wall of the core, and it will get distributed in the hollow space, and it will form the molding. Now after some time, this molding will get cooled, and it will become strong and solid. Now the mold opens, correct, and this molding, which has shrunk because When the plastic material cools, it shrinks. It shrinks. So the material is like this. So when it shrinks, it will shrink on the core and it will grip it very firmly, very strongly. And when the mold opens, it will the molding will come on the core. It will come on the core. So this is the process of forming the molding. Now you can see, now you can see that here are ejector pin holes. This is the this is the now here you can see that this is one hole. This is one hole. You can see this is the other hole and this is the third hole. Now the ejector pin will come. This is the ejector pin. This is the ejector pin. It is a simple pin with a head. Now this ejector pin will come through this hole. Now the part of the ejector pin is on the molding, that is the top surface of the ejector pin. A part of the top surface is touching the bottom surface of the molding, that is the side wall of the molding. Now you can see here, if I push it, if I push it, see, now you can see, if I push it, see, the molding is ejected. So the ejector pin, this ejector pin comes and this surface, part of this surface is at the bottom of the molding, that is the bottom of the side wall of the molding. And when this ejector assembly is actuated, the molding is ejected. So this is how the molding is formed inside impression and ejected. So this is the basic fundamental of injection mold design. Now my book has been published. See, this is my book. This is a Kindle book and it has been published on Amazon.in. So you can buy this book, and in India it is selling for 300 rupees, and elsewhere like US and other UK etc. the cost is $25, which is very nominal. So you can get it through Amazon .in India and Amazon.com in US. It explains everything. It is a skill book. It is a skill book. And if you read through, you will understand the whole thing, and you can design a simple injection mold. Thank you.